Mixtures are made up of particles of substances which have not been joined together in a chemical reaction. Here is a mixture of sulfur and iron. They have not reacted chemically and can be separated easily. The iron is magnetic and can be easily collected up with a magnet. My cup of tea is obviously a mixture. It has several ingredients. But how about the ingredients themselves? Here's a question for you. Are each of these, milk, sugar and water in my tea, mixtures or compounds? Why not stop the tape and have a think? So, which of these three examples are mixtures and which are compounds? The answer is only the sugar is a compound. It only contains one substance. Remember, in a compound, the particles are combined chemically and they are all the same. Milk is a mixture of fat and water, minerals and vitamins. And ordinary tap water, well, it looks pure enough, but it is in fact a mixture. There are other things in it. In this next clip, Femi goes under the Derbyshire Hills and takes a closer look at the local water supply there.
Stalactites are formed by dripping water over thousands of years.
The drip of water dries up and leaves behind tiny crystals of calcium carbonate.
Calcium carbonate, a compound. So already we know that the local water must contain calcium.
And the band of orange on the wall indicates that there's iron in the water that's passed over this area.
So that could be in the water too?
Correct.
Alan showed me examples of other substances like manganese left behind by the water. It looks like there could be much more than just the elements hydrogen and oxygen in the local water.
This is the lab where the local water is tested and Karen here does the testing. Can you help me out here? I'm a little bit confused. The locals call this water pure. The leaflets call this water pure. Even the bottle claims it's pure, and yet it looks likely that it does actually contain calcium, iron and manganese.
Yes, you're right to be confused. That's because the everyday use of the word pure is somewhat very different to the scientific use of the word pure. This sample of water is actually a mixture of water and all of those minerals that you mentioned earlier. Pure water contains entirely the elements hydrogen and oxygen.
So where can I find pure water then? Scientifically pure, I mean.
Well, if we take this sample of water for starters, I'll show you what we can do.
Karen heats up the mineral water till it starts to boil. The minerals in the water can't boil off, but the pure water can. The pure water vapour passes up through this tube. The tube is kept very cool, so the water vapour condenses and water trickles out the end. Scientifically pure water. But when all the water's boiled away, what's left in the flask? You can clearly see traces of minerals left behind on the side of the flask.
So scientifically, the mineral water is no more pure than my fizzy drinks.
Indeed, they're mixtures too.
But that is pure water.
Yes, this is pure water. It's actually tasteless, and it's the minerals that give the water its unique taste.
I think I'll stick to the natural, but not scientifically pure, but some water. Cheers.
So when referring to the word pure in chemistry, pure means a substance which contains only one type of particle. Mixtures are a combination of substances that are not chemically combined and can be separated. So ordinary water that we drink and use for everyday purposes is in fact a mixture of water and minerals that are dissolved in it. We can get pure water with nothing else in it by distillation, but that's in the next section that we're going to look at.